Hello everyone. Today class number 26 for electrical machine 2. Class 26 for electrical machine 2. Okay. So in this class I will complete a numerical regarding the single phase induction motor tests. So problem number 1, write following data relates to tests on a 110 volt, 150 watt, 110 volt, 150 watt, 50 hertz, 6 pole single phase induction motor. Okay, so your result is no load test. For no load test will be 100 volt, 65 watt and 3 ampere. Okay, and blocked rotor test it will be 50 volt, 210 watt and 6 ampere. Okay, so write the stator winding resistance is 2 ohm, and during the block rotor test the auxiliary winding are kept open. The auxiliary windings are kept opened. Determine the equivalent circuit parameters. Determine the equivalent circuit parameters and also find the core, friction and windage loss. Okay, so let us start this numerical. To start this numerical, you have to find first you have to perform the blocked rotor test. Okay, so do heading blocked rotor test. Okay, so during the blocked rotor test, so your VSC equals to 50 volt. This is voltage 50 volt, and WSC equals to 210 watt, right? And ISC equals to 6 ampere. Okay, so these three readings are collected from voltmeter, wattmeter and ammeter respectively. Okay, and the stator resistance is 2 ohm. It is given, that is R1 equals to 2 ohm. It is given, right? So from the first one you can write RSC, that is the short circuit or the blocked rotor test. During the blocked rotor test, what will be the equivalent resistance of the circuit, right? So RSC equals to WSC by ISC square, right? For blocked rotor test, W equals to I square R. Okay, so blocked rotor test, W equals to I square R. So from this concept you can develop this 210 by 6 square ohm, that will be how much? 5.88 ohm. Okay, so RSC equals to 5.88, and from the equivalent circuit of the RSC during the blocked rotor test, your equivalent circuit equals to R1 plus R2 by 2 plus R2 by 2, right? So your RSC equals to R1 plus R2 by 2 plus R2 by 2. So that will be equals to R1 plus R2, and if we put RSC value over here 5.88, and if we put R1 equals to 2 ohm, then your R2 will be 3.88 ohm, right? So this is one of the parameter circuit parameter of the single phase induction motor. Okay, so now write rotor resistance due to forward field. What will be your answer? So whatever the R2, it will be divided by 2, that will be 3.88 divided by 2, right? So I am drawing first, okay? So it will be better to understand. First draw it. Roughly I am drawing, so you please draw it fairly. Okay, so this is total voltage applied over here. So this is your R1 by 2, this is your X1 by 2, right? This is R1 by 2, this is X1 by 2, this is another R1 by 2, and this is X1 by 2, and this is XM by 2, and this is XM by 2, this is XM by 2, this is R2 by 2, and this is X2 by 2, and this is R2 by 2, and this is X2 by 2, right? So you have to find these parameters. So rotor resistance due to forward field, that will be 3.88 by 2, that will be 1.92. So similarly, rotor resistance due to backward field will be equals to again R2 by 2, 1.92 ohm. Okay, so up to this much it is clear to you, right? So I am finding this R1 by 2 and R1 by 2 value. Okay, so next, right? So from this given data we can again solve that ZSC equals to what? ZSC equals to nothing but VSC by ISC, because from the Ohm's law V equals to I into Z, from this concept we can calculate VSC by ISC. VSC equals to 50 volt and ISC equals to 6, right? So your ZSC equals to 8.33 ohm. Okay, so again from the definition of ZSC, it will be equals to XSC whole square plus RSC whole square. Okay, so ZSC equals to 8.33. If we square it, then XSC square plus RSC. So what is your RSC? RSC is what will be the value of RSC? 5.88, right? So it will be 5.88 whole square. So from this relation, XSC can be calculated by 5.9 ohm, right? So XSC equals to 5.9 ohm. Now XSC equals to what? From the equivalent circuit of it during the block rotor test, XSC is nothing but X1 by 2 plus X1 by 2 plus X2 by 2 plus X2 by 2. Okay, so that will be equals to X1 plus X2, nothing else. Okay, during block rotor test, XSC equals to X1 plus X2. Okay, now you have to assume X1 equals to X2. Now you have to assume, because there is no hint of this X1 X2 separate ratio. Okay, so if there is no hint is given to you, then you can assume that the X1 equals to X2, that will be X1 equals to X2 equals to XSC by 2. That will be how much? It will be 5.9 by 2. That will be 5.9 by 2. It will be 2.95 ohm. Okay, so X1 X2 already I have been calculated. So X1 X2 I have already been calculated. So from this block rotor test we have the results that R1 equals to R1 by 2 equals to R1 by 2, that is these two resistance will be equals to how much? It will be 1.92 ohm. Okay, X1 by 2 equals to X1 by 2 equals to X2 by 2 equals to X2 by 2. That means 4 component, 1, 2, 3 and 1, 2, 3, 4. These 4 component we have calculate that is 2.95 by 2, right? So how much it will be? 1.475, right? Oh, so these parameters already I have been calculated during the block rotor test. So now I will move into the no load test. Okay, So now moving into the no load test. So no load test. So what are the data for no load test? VNL equals to 100 volt, WNL equals to 65 watt, and INL equals to 3 ampere, right? 100 volt, 65 watt, 3 ampere. Okay, these three data already I have been given. Okay, so here from what will be the first formula? WNL equals to, you can write VNL INL cos theta NL. Okay, cos theta NL. Cos theta NL is the no load power factor. Okay, so WNL equals to 65 and VNL 100, INL 3, and cos theta cos phi NL. So cos phi NL equals to 65 by 100 into 3. Okay, so if we calculate it, then the result will be 0.2167. 0.2167 cos phi NL. Okay, so next sin phi NL. So what will be the sin phi NL? Root over of 1 minus 0.2167 whole square, right? So it will be the sin phi NL. So 0.9762. It will coming 0.9762. Okay, so sin theta is already been calculated. So now after that, so ZNL equals to what? VNL by INL. So VNL equals to 100 and INL equals to 3. So it will be 33.34 ohm. Okay, so ZNL equals to 33.34 ohm. So XNL equals to what now? And RNL equals to what? So XNL equals to this ZNL sin phi NL. Okay, so 33.34 into 0.9762. So after multiplication we have 32.54 ohm. Okay, so XNL equals to 32.54 ohm. So total reactance equals to during the no load test equals to 32.54 ohm. Okay, so what will be the XM? So now let us find XM, because XM only the term which is left to find. Okay, so XM equals to 2XNL minus X2 minus 2X1, right? So from this relation we can easily calculate XM. So because already X2 and X1 already have been calculated during the block rotor test. Okay, so XM equals to 2 times of 32.54 minus X2 minus 2X1, that is 2.95, right? So 2.95 minus 2.95 into 2. Okay, so after calculate it, so X1 equals to 2.95 into 2, because here 2 into 2 times of here. So X2 equals to again 2.95, because we are assuming X1 equals to X2, right? Which will be equals to XSC by 2, right? So this is the concept. So already I have been calculated in block rotor test. So from this same concept you can put the value, and XM equals to, your result will be 56.23 ohm. XM equals to 56.23 ohm. Okay, so what will be the magnetizing reactance during forward field and during the backward field? That is XM by 2, which will be equals to 28.115, and XM by 2 again 28.115. Okay, these two reading are we have to put over here. Okay, so this is all about the circuit parameters. Okay, so now I have to find the friction and windage loss, right? So the auxiliary open, determine the equivalent circuit parameters and also find the friction and windage loss. Okay, so how to find the friction and windage loss? While no load test is conducting, then the power balance, then the core loss, or first write core loss equals to total power developed minus copper loss. Okay. So total power equals to how much? 65 watt, and copper loss equals to INL square plus into R1 plus R2 by 4, because from this from the theory we have been calculate that during the no load test, only this resistance is prominent inside for the induction machine. Okay, so 65 minus, it will be 3 square, because 3 ampere current is over here. So 3 square plus R1 will be 2, right? It is given R1 equals to 2 ohm. The stator resistance is 2 ohm, and R2 equals to 3.88 divided by 4. Okay, so 65 minus 26.73, which will be equals to 38.27 watt. Okay, so also find core loss and friction and windage loss. So that is core loss plus friction and windage loss. Okay, so there are 2 more losses are there, right? Friction and windage loss. Okay, so total core loss and friction and windage loss equals to total power developed minus copper loss. Okay, so total power developed equals to nothing but this core loss plus friction windage loss and copper loss. Okay, so that is no load test is conducting to find the power, right? So this power is utilized by no load. That means that this power totally utilized by the loss component of the motor. Okay, so the loss components of the motors are, that is core loss and friction and windage loss and copper loss. Okay, so this is all about your numerical regarding single phase induction motor. Okay, so the numerical is completed. Now I will move into the starting mechanism for single phase induction motor. Okay, so starting mechanism for single phase induction motor, right? Starting mechanism of single phase induction motor. Actually starting mechanism is nothing but the classification of single phase induction motor. Okay, so according to the starting mechanism, induction motor can be classified into broad 4 categories. Okay, according to the starting mechanism, single phase induction motor can be classified into broad 4 categories. Okay, there are 4 classifications are there, as well as 4 broad mechanisms, right? First one, right, split phase mechanism. Okay, second one, shaded pole mechanism. Third one, repulsion start motor mechanism. And fourth one, reluctance start motor mechanism. Okay, so in your syllabus only split phase belongs to, and this split phase again classified into 4 categories. Okay, this split phase again classified into 4 categories. So these 4 categories you have to learn very well. You have to discuss in detail. Okay, so in the following next classes we will discuss these 4 categories. Okay, so write down the categories first. Resistance split phase, resistance split phase, single phase induction motor, and second one capacitance split phase, single phase induction motor, and third one capacitor start, capacitor run, single phase induction motor. Capacitor start, capacitor run, single phase induction motor. And last one permanent capacitor run, single phase induction motor. Okay, so these 4 are most important and we have to discuss in detail, and which belongs to your syllabus also. Okay, so today's class up to this much. Next day I will start one by one classifications, and after that I will be have to prove something, and some extra 2 or 3 topics are remaining. So then this module is also completed. Okay, so waiting for that day. So okay, thank you for today.